Good morning, class. No one showed up for the math intervention this morning, but it is very important because today we were going to review the SchoolNet test, and this was the one where we were really trying to see if we could reach that grade level standard. So we'll look at that this morning. Even though you're not here, you can watch this at a different time, and that will be perfectly okay. So on the first one, we had 5/8 plus, I don't want to clear that, so I'm trying to decide what I'm going to do about that. We have 5/8 plus 1/8. So we know that when we add fractions, we do not add the denominator. So that would stay the same, and that would be 6/8. The reason we don't add the denominator is because it's a label. It's like 3 chickens plus 4 chickens. That's what it is. That's 7 chickens. So if it's in eighths, that's how many pieces there are. That's not going to change unless you're creating an equivalent fraction, which is what we're going to do next. So if you look at the answer choices, 3/8, you can't turn 6/8 into 3/8 because when you create an equivalent fraction, you have to divide or multiply the fraction by the same number, numerator and denominator. And we know that we're going to have to do that because 6/8 is not at any of our answer choices. So 3/8 is not going to be our answer. 3/16. In order to get to 16ths, you would have to multiply the top and the bottom by 2, and that would be 12/16. Well, that's not what it says. It says 3/16, so that can't be our answer. Now, if you look at A, you could divide 6 by 2 and 8 by 2, and that would get us to 3/4, okay? So that's how you would do that one. Let's go on to look at number 2. The gray area of the figure below represents a fraction. Okay, what is that fraction? You can tell instantly there's 2 pieces. One is there, so that is going to be 1/2. Now we're going to look at which pieces we could add together that would equal 1/2. So as I look at those, A is 1/4 plus 1/2. So if I put those two together, and I'm just going to do it on this other one, it would be 3/4, okay? So that's not going to be it. If I add this fourth to this fourth, 1/4 plus 1/4, that would give me 1/2. And I also know that 1/4 plus 1/4 equals 2/4. And then if I divide the top by 2 and the bottom by 2, then I get 1/2. And then I also know if there's 4 pieces and 2 are shaded, that is 1/2. Okay? So I don't know what I'm doing here this morning. So that is how you would do that one. Moving on to the next question. Number 3, the model below is shaded to represent a mixed number. So remember, a mixed number is going to have a whole and then a fraction with that. So the only ones that we're looking for is one that would represent that. So 5/5 plus 3/5 plus 4/5. Well, that last one's not 4/5, so it can't be that. 1 plus 4/10. Well, those are split into fifths, not tenths. And if we split those fifths into tenths, then this one, if this was split into tenths, that would be 6/10, and this one would be 2/10, which would actually be 8/10. And this is not 8/10. So the next one would be 1 plus a whole plus 3/5. There's not 2 wholes there. 5/5 is 1 whole, and then it has another 1, so there's not another whole there anywhere, so it can't be that one. So it has to be the last one. I keep hitting that. So we've got 1, and then we have 4 out of our fifths, right? So really, if you just eliminated this one and put that one there, that's kind of what that would look like, 1 4/5. So that one is that's how you would do number 3. Number 4, Braden folded a sheet of paper into 4 equal parts. As shown, he cut the paper along the folded area and used 3/4 of the pieces for a project. Which number sentence shows how to find the fraction of the sheet of paper Braden has left? So we're looking for that. So you've got 4/4 because you've got 4 pieces here. And then you're going to take 3 of those away. And then you're going to have 1 of those left because it says he used 3/4. And how much does he have left? So if you use half of a bottle of toothpaste, how much do you have left? You have half. That's a subtraction problem. So that's how you know the answer is C for that one. Number 5. What is the equivalent fraction for the shaded portion of the figure? Okay, so we know that there's 8. And we know that there's 6 shaded, but you could also look at this in groups of fourths. And then you've got 3/4 there. Also, knowing in its equivalent fraction, divide 6 by 2, divide 8 by 2, and you get 3/4. So that's how we know that the answer is 3/4 for that one. Because remember, a fraction is how many pieces there are and how many is represented, how many you're looking at out of that, how many are shaded. 2 fraction models are shown below. Which number sentence is true? Well, 4/6 is greater than 5/12. So you can see that right there. We did a lot of practice on that one. And by the way, number 5, our class had a really great high average for that question. Number 7. 4 groups in Mr. Chow's class started collecting aluminum cans for a recycling project. The table below shows the weight of cans in pounds each group collected. So group 1 is 3/5, group 2 is 7/10, group 3 is 3/6, which is also 1/2, 3/6. Half of 6 is 3. Number 4 group had 5/12 of a pound, which inequality correctly compares the weights. 3/5 versus 7/10. Now, both of those are greater than 1/2. So you can't really use a half to help you. How close are they to a whole? They're both pretty close to a whole. So in order to compare this, actually, I'm going to create an equivalent fraction to do that. So 3/5 is going to be equal to how many tenths? 6/10. So that can't be right because 3/5 is smaller. 5/12 is greater than 3/6. Again, I can create an equivalent fraction, but I'm going to have to change the 6 into 12ths because if I change the 12ths into 6, I would have to cut 5 in half. You can't have a decimal with that fraction. So 3/6 would be equal to 6/12. We also know that because 3/6 is 1/2. So 6/12 is greater, so that's not right because that should be, this one should have been going this way and this one should have been going this way. 3/6 is greater than 3/5. Now here, I cannot create an equivalent fraction to get them to the same denominator that way. But what I can do is I can look at it related to a half. 3/6 is 1/2, and then 3/5 is a little bit larger than a half. So, because 2.5 is half of 5. So this one would need to be this way as well. So 3/5 is larger than 3/6. And you could draw that out to be able to tell that as well if you wanted to. So I've got my 3/6 and I've got my 3/5, and you can tell that's just a little bit larger. That's the great thing about 4th grade fractions. And then you'll see here 7/10 and 5/12. 5/12 is less than a half and 7/10 is more than a half. So you should be able to tell that that one is larger. So we will look at the next one. I'm sharing with Daniel right now because, hey Daniel, can you hear me? I don't think he can hear me. Hey Daniel, can you see my screen? Okay, I've just been reviewing the test from fractions, so we're going to go on with that. I'm making a video so that the people who didn't come can watch it. Okay, number 8. Which inequality is true? So we want to look at which one of these is true. Is 5/10 larger than 3/4? Is 5/10 going to be larger than 3/4? So we know that 5/10 is equal to 1/2, right, Daniel? Yeah. So 3/4 is going to look like this. So is 5/10 larger than 3/4? That is absolutely true. So let's look at the next one. 7/10 and 3/4. Which one of those is larger? No, they're not equal. So 7/10 is larger than a half. So remember, we can always draw this stuff out, and I'm just going to do it like this. So that's 7/10, and then here is 3/4. They do look a little bit equal, but I think 3/4 is going to be larger. Okay, and for the next one, 2/5 and 2/6. Is 2/5 smaller than 2/6? Okay, so remember, we can always draw these out. So if I've got my fifths, and then I've got my sixths, and I didn't do those exactly right, so hopefully it shows up. Here's my 2/5, and here's my 2/6. So 2/6 is smaller, so that would need to be going that way. So for the last one, you can tell there that that's the answer, but we want to know why that's the answer. Can either of you explain why that one's the answer? Not a half and a half, but it is larger than a half. So that's how you can, yeah. So that's how you can know that one. And you can also always draw those fractions out, because when you draw those fractions out, you can tell what they are. Which number sentence correctly compares 28 hundredths to another decimal? So we're wanting to figure out 28 hundredths to another decimal. Why is B the correct answer? Excellent, excellent explanation, Arthur. Can someone explain to me why number 10 is A? Good job. Okay, so for number 11, that's kind of the same concept. Arthur, can you tell us why the answer would be D? Oh, I'm sorry. 45 hundredths plus 2 tenths. What would the answer be for that? Mm-hmm. Good job. Ellie, are you in here? I thought I saw Fernando come in. Yes? This is it. Well, we're getting ready to start our next meeting. This is a review, so we just have a little bit more left. Number 12, how is the fraction 1 5/10 written as a decimal? Fernando, if you're in here, how would you write that as a decimal? One and he was. I saw him. Okay. Well, will someone explain to me why 1 5/10 what it's written as a decimal? 1 5/10. Okay. Yeah, so just remembering when we have our decimals, this is the tenths place and this is the 100ths place. So you would have the 5/10 would go there and then the 1 would be in the ones place. So not too bad. And let's look at our next one. Each circle in the model below represents one whole. The model is shaded to represent 8/6. What equation can be used to represent this model? So with this was looking at our unit fractions that we talked about. So we have 1/6 8 different times. So that would be 1/6 times 8. Yes, 8 times 1/6 would work as well. And the last one, Natasha's weekly math homework assignment has 40 problems. She solved 3/8 of these problems on the first day and 8 problems on the second day. What is the total number of problems Natasha solved? This one was a multi-step problem. So first, what would you do? Yeah, you could. 40 times 3/8. You could divide that into eighths, yes. So how much would each eighth have in it? So the whole's going to be worth 40. 5. Okay. I'm having a hard time with my So each one is worth 5 and we have 3 of those. So that is 15 plus 8, which gives us what? This is a review. It's not 10 o'clock yet. This is for some students that I invited to a fractions meeting. So this would be 3/8 of 40 is 15. And then we have the 8 problems that we add to that, which would be 23. So those of you that took the fractions test that I invited you to the intervention, do you guys have any questions about that? Okay, I'm going to upload this video for people who did me so they can get that review as well.